Demo Air Passengers 2. Problem statement. In this demo, we will be using the Air Passengers dataset to 1. Fit a model using an ARIMA algorithm. 2. Calculate forecasts. The initial steps are already covered in the previous demo. Let's skip to the model building. Forecasting a time series. Now that we have made the time series stationary, let's make models on the same series. We will use statistical modeling method called ARIMA to forecast the data where there are dependencies in the values. To find the P and Q values for the model, we will use ACF and PACF plots. Plotting ACF. Initializing the plot and applying ACF. Calculating the axes. Let us see the plot. The AFC curve crosses the upper confidence value when the lag value is between 0 and 1. Thus, the optimal value of Q in the ARIMA model must be 0 or 1. Plotting PACF. Initializing the plot and applying ACF. Calculating the axes. Let us see the plot. The PACF curve drops to 0 between lag values 1 and 2. Thus, the optimal value of P in the ARIMA model is 1 or 2 point pi. Model predictions. The first step is to store the predicted results as a separate series and observe it. Note that these start from 1949-02-01 and not the first month. This is because we took a lag by 1 and the first element doesn't have anything before it to subtract from. The way to convert the differencing to log scale is to add these differences consecutively to the base number. An easier way to do it is to first determine the cumulative sum at index and then add it to the base number. The cumulative sum can be found as You can quickly do some calculations using the previous output to check if these are correct. Next, we add them to the base number. For this, let's create a series with all values as the base number and add the differences to it. This can be done as Finally, we have a forecast on the original scale. Initializing ARIMA model. Plotting the ARIMA predictions. Assigning RMSE value as the plot title. The orange curve is our prediction, which has a RMSE of 52.1841. While our model is good at predicting the trend, it fails in capturing the seasonality. Great, we have seen how to explore and examine the time series data. Let's quickly recap the steps we covered. 1. Perform exploratory data analysis. 2. Perform decomposition of data. 3. Perform stationarity check. 4. Fit a model using an ARIMA algorithm. 5. Calculate forecasts. This brings us to the end of time series modeling. You are now able to explain time series analysis and build time series models using ARIMA. This brings us to the end of time series modeling. You are now able to explain time series analysis and build time series models using ARIMA.